Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS3492 Database Management Systems and the unit is Transactions. The topic is Deadlock Handling. Deadlock. In a database, a deadlock is an unwanted situation in which two or more transactions are waiting indefinitely for one another to give up locks. Deadlock is said to be one of the most feared complications in database as it brings the whole system to halt. For example, system is deadlocked if there is a set of transaction such that every transaction in the set is waiting for another transaction in the set. Consider the following two transactions T1, T2. In particular T1 transaction, the right of one item, that is A value is right. After that the T2 transaction also write the same data item right. Then the transaction T2 write the B data, at the same time the transaction T2 write the same data items. These are the two situations. In this schedule with deadlock means at the time of T1 transaction, first the lock has made on the same data item A. At the time the data item is updated, that is right of A value is right. After that the transaction T2 made lock on data item B. At the time the data right for B. Wait for the data item, the T2 transaction is wait for transaction T1 because the transaction T1 has made lock on the data item A. It must wait for some time. At the same time T1 transaction is also wait for the data item B because it is locked over the transaction T2. This is the deadlock. That means the program A and program B, there are same task at a time, same record in the same table. There are two records, record X and record Y. These two records are accessed by this programs A and B. First the A transaction logged the one item, X item. This is the example diagram for the above transactions. At the same time the transaction B program B logged the item Y. The both program A and B are waiting for the record X and as well as the record Y because they that are already occupied by the that are already logged by some other transactions. Okay. This situation is known as deadlock. The deadlock handling. Deadlock prevention protocol ensures that the system will never enter to the deadlock states. Some prevention strategies are followed. First one is the first approach one. Approach one is the require that each transaction logs all its data items before it begins executions. Either all are logged in one step or none are logged. The main disadvantages of this approach is hard to predict before the transaction begins what data items are logged. Data item utilization must be very low. Then next approach is the assign a unique timestamp to each transaction. These timestamps only decide to whether a transaction should wait or roll back. Then next approach is then these are the deadlock prevention schemes. Some of the deadlock prevention schemes. First one is the wait die scheme. Then second one is the own wait scheme. Wait die means this is one of the non-preemptive technique. When transaction Ti requests a data item concurrently held by transaction Tj, the Ti is allowed to wait only if it has a timestamp smaller than of the Tj. Otherwise Ti is rollback, that is dies. Older transaction may wait for younger transaction 1 to release the data item. Younger transaction never wait for older transaction. They are rolled back instead. A transaction may die several times before acquiring needed the data items. Next one is the wound wait scheme. This is one of the preemptive technique. When transaction Ti requests a data item concurrently held by the Tj, Ti is allowed to wait only if it has a timestamp larger than of the Tj. Otherwise, Tj is rolled back. Older transaction wounds of a younger transaction instead of waiting for it. Younger transaction may wait for older ones. Deadlock detection. How to detect the deadlock? Deadlocks can be described as a wait for graph which consists of a pair G equal to V comma E. V is a set of vertices, E is a set of edges. If Ti tends to Tj is in E, then there is a directed edge from Ti to Tj, implying that Ti is waiting for Tj to release a data item. If the system is in deadlock state, if and only if the wait for graph has a cycle, must invoke a deadlock detection algorithm periodically to look for cycles. This is the wait for graph cycle without a cycle. First graph. Then second graph is a wait for graph with a cycle. Recovery from deadlock. The common solution is to roll back one or more transaction to break the deadlock. Two actions need to be taken. First one is a selection of victim. Then second one is a rollback. Selection of victim means set of deadlocked transaction must determine which transaction to roll back to break the deadlock. Consider the factor minimum costs. Then second one is a rollback. Once we decided a particular transaction must be rolled back, must determine how far this transaction should be rolled back. Total rollback. Then there are two types of rollback. First one is a total rollback. Then second one is a partial rollback.